This lesson today is on conditional statements. And if you haven't heard of what a conditional statement is, it is an if-then statement. So, anytime you hear if something blah blah blah, then something blah blah blah, that is considered a conditional statement. So, it's simply an if-then statement. So, for example, if you are not completely satisfied, then your money will be refunded. This is a conditional statement because it's simply an if-then statement. Okay, the hypothesis is the part following the if in an if-then statement. So whatever comes after the if until you get to the then, that is the hypothesis. The conclusion is the part following the then. So whatever comes after the then, that's the conclusion. Okay, so once again, a conditional is simply an if-then statement. The hypothesis comes after the if, the conclusion comes after the then. Today's lesson is going to kind of seem like an English lesson because we're going to be doing quite a bit of writing, and so I apologize for that, but this is our logical thinking part of math. So in math, yes, there's a lot of computation, but there's also logical reasoning to help you with your problem-solving skills. And so this is more about our logical thinking, our reasoning skills, than it is so much about writing the sentences. Okay, the first set of examples tell us to identify the hypothesis and the conclusion. Okay, so number one says, if today is the first day of fall, then the month is September. So remember, the hypothesis, that's what follows the if. So I would write, today is the first day of fall. So the hypothesis is what follows the if. The conclusion is the part that follows the then. The month is September. So once again, here we are in geometry, lots of vocabulary. Hypothesis, conclusion. Hypothesis is after the if, conclusion is after the then, and the if-then statement itself is called the conditional. Okay, number two. If y minus 3 equals 5, then y equals 8. So what do you think the hypothesis would be? Y minus 3 equals 5. That's the part that follows the if. And so what's our conclusion? Y equals 8. That's the part that follows the then. Okay, I think you probably understand that. So now I'm going to come down here and I'm going to try to write these sentences as a conditional. So if I want to write the sentence as a conditional, that just means you want to make it an if-then statement. So number one says, a rectangle has 4 right angles. I want the sentence to basically say the same thing, but I need to put an if and a then in there, and it has to make sense. And it has to be good grammar. So a rectangle has 4 right angles. So I could say, if a figure is a rectangle, so if a figure is a rectangle, then it has 4 right angles. So if a figure is a rectangle, then it has 4 right angles. This is saying the same thing as it did originally. A rectangle has 4 right angles. I have just changed it into an if-then statement called a conditional. So number 2 says an obtuse triangle has exactly one obtuse angle. So I could say something like, if a triangle is obtuse, if a triangle is obtuse, then it has exactly one obtuse angle. Okay, so that's a conditional. A conditional is an if-then statement. Remember the part that comes after the if, that's the hypothesis. And the part that comes after the then, that's the conclusion. So those are the words that we've learned so far on this front page. Let's go ahead and go to the second page. Okay, a conditional. It can have a truth value of either true or false. And if I want to show that a conditional is false, I need to find a counterexample. So we have talked about this word before. A counterexample is an example that shows the conclusion to be false. Okay, so let's look. These examples tell us to show that the following conditionals are false by finding a counterexample. 1 says, if it is February, then there are only 28 days in the month. What do you think about that? If it is February, then there are only 28 days in the month. Do you think that's true or false? This is false, and why? It could be a leap year. And how many days does a leap year have in it? 29 days. So if it's February, then there are only 28 days in the month. That is false because it could be a leap year with 29 days. This guy right here is called the counterexample. So a counterexample is an example that shows a conclusion to be false. Okay, I'm going to go to number 3. Number 3 says, if you live in a country that borders the United States, then you live in Canada. What do you think? If you live in a country that borders the United States, then you live in Canada. False. You could live in Mexico. So I'm just going to go ahead and write Mexico. And Mexico here is my counterexample. It's my example that shows my conclusion to be false. Okay, number 4 says, if an angle is obtuse, then it has a measure of 100 degrees. If an angle is obtuse, then it has a measure of 100 degrees. False. To be an obtuse angle, it just needs to be bigger than 90 degrees, but less than 180, so maybe it's 120 degrees. And that 120 degrees is my counterexample. That's my example that shows the conclusion to be false. Number 2, I think I want to talk to you about that one in class, because a lot of times students don't catch that one. Okay, we have another vocabulary word, converse. The converse, it switches the hypothesis and the conclusion of your conditional statement. So in these examples, I want to write the converse, I want to determine the truth values of our original conditional and the converse, and if something's false, I'm going to give a counterexample. So first, let's just read this first statement and decide if it's true or false. If 2 lines intersect to form right angles, then they are perpendicular. So if 2 lines intersect to form 90-degree angles, right angles, then they're perpendicular, and that is true. So perpendicular means that lines intersect and 90-degree angles are formed. So if we have lines that are intersecting and 90-degree angles are formed, then yes, that means those lines are perpendicular. So that is true. Okay, so what a converse does is it flip-flops the sentence. It switches the hypothesis and the conclusion. So the then will become the if part, and the if will become the then part. So it's just going to flip-flop the sentence. So if, and instead of they, I'm going to say the lines. If the lines are perpendicular, then they intersect to form right angles. So if the lines are perpendicular, and I am going to use this symbol right here to indicate perpendicular, the upside down T. If the lines are perpendicular, then they intersect to form right angles. Okay, so the converse, it flip-flops the sentence. The if becomes the then becomes the if. So it switches the hypothesis and conclusion around. Okay, now I want to determine if the converse is true or not. If the lines are perpendicular, then they intersect to form right angles. That is true. That is what perpendicular means. So if the lines are perpendicular, so if I have perpendicular lines, then yep, that means they intersect and they form 90-degree angles. That is true because that is what perpendicular actually means. You have lines that intersect and they form 90-degree angles when they do it. Okay, let's try this one. Let's see if this is true or false. So this is our original conditional. If x equals 9, then x plus 3 equals 12. Do you think that's true? If x equals 9, then x plus 3 equals 12. If I put 9 right there in that x, does 9 plus 3 equal 12? Yep, so that is true. Okay, so what the converse does is it switches the converse around, or the conditional around it, flip-flops it. So this is going to be the if part. So if x plus 3 equals 12, then x equals 9. So the converse just flip-flops the sentence. Flip-flop. Now, let's decide if this is true. If x plus 3 equals 12, then x equals 9. Well, if you solve this equation for x, you would subtract 3 from both sides, and yeah, that would give you x equals 9. So that is true. Okay, I think we'll talk about this next one, which you don't actually even see my problem here. I think we'll talk about that when I see you in class. Okay, let's go to the next page. Okay, I want to go down to the next vocabulary word, and we can practice, some of this stuff when I see you, so I don't want you to be overwhelmed with the vocabulary. So inverse, this negates the hypothesis and the conclusion of the conditional statement. So let me show you. Here's a conditional. If it snows tomorrow, then we will go skiing. What the inverse is going to do is it's going to negate both our hypothesis and conclusion. So instead of if it snows tomorrow, it will be if it does not snow tomorrow. And then instead of then we will go skiing, it will be then we will not go skiing. So the inverse, it takes your original conditional and it negates the hypothesis and it negates the conclusion. So it turns it to the opposite. Okay. Our last word is contrapositive. And what the contrapositive does is it negates the converse. So remember how the converse flip-flop the sentence? Flip-flop. Well, the contrapositive is going to take that flip-flop and negate it. So if it says is, you'll say is not or does not. If it says it isn't, you'll say it is. It makes the opposite. It negates it. Okay, so let me show you a conditional. If it snows tomorrow, then we will go skiing. So the converse is going to flip-flop it. So it will be if we go skiing, then it will snow tomorrow. And I'm just going to abbreviate tomorrow. If we go skiing, then it will snow tomorrow. And I have to change the way it is worded just a little bit so it makes sense. Okay, so the converse flip-flops the sentence. Okay, and then the contrapositive is going to negate the converse. It's going to make this negative. So instead of if we go, it will be if we don't go skiing. And then instead of then it will snow, it will be then it won't snow. So if we don't go skiing, then it won't snow. Okay. So I imagine at this point you're like, what? Too many words. I can't keep it all straight. So I am just going to come down to where we do all three things that we've just talked about. And then we're going to look at the truth value of these. So let's go to this number 1 down here. So I'm going to write the inverse, the converse, the contrapositive, and I'm going to decide if they're true or not. Remember the original statement, that's your conditional. So let's look at the original statement and decide if it's true or not. If you live in Miami, then you live in Florida. If you live in Miami, then you live in Florida. This is true unless there happens to be a Miami, some other state, like a Miami, Kansas, which I know there's not. So for the most part, I'm going to say that this statement's true, but if somebody knew that there was a Miami, Missouri, or a Miami, Arkansas, then this would be a false statement. But because I don't know of any other Miami, as far as I'm concerned, I think this is a true statement. If you live in Miami, then you live in Florida. Okay, so what the inverse does is the inverse negates the original statement. It negates the conditional. So instead of if you live, it's if you don't live. So if you don't live in Miami, and then instead of it saying then you live, it will say then you don't live. In Florida. So if you don't live in Miami, then you don't live in Florida. So let's think about that and decide if that's true or not. If you don't live in Miami, then you don't live in Florida. If you don't live in Miami, then you don't live in Florida. False. You could live in Fort Lauderdale. And I'm not going to write that whole sentence out. You could live in Boca Raton. You could live in Orlando. So just because you don't live in Miami doesn't mean you don't live in Florida. Okay, so that's false. Okay, converse. Converse takes your original conditional and it flip-flops it. So it starts back here. If you live in Florida, then you live in Miami. So if you live in Florida, then you live in Miami. if you live in Florida, then you live in Miami. What do you think? True or false? If you live in Florida, then you live in Miami. False. You could live in Fort Lauderdale again, or any of those other places I mentioned just a moment ago. So Fort Lauderdale is my counter example. Okay. And then the contrapositive. The contrapositive, it takes this converse and it negates it. So instead of if you live, it's if you don't live. So if you don't live in Florida. So if you don't live in Florida, and then instead of then you live, it's going to be then you don't live. Then you don't live in Miami. Let's think about this. If you don't live in Florida, then you don't live in Miami. Well, that's true unless there happens to be a Miami in some other state. So if you don't live in Florida, then you don't live in Miami. So that's true unless there happens to be a Miami in some other state. Now, one thing I want you to know is the original conditional and the contrapositive, they always have the same truth value. So they will always have the same truth value. Let me write it down and then I'll explain what I mean. The conditional, the original statement, and the contrapositive will always have the same truth value. If the original statement, the conditional, is true, the contrapositive will be true. If this is false, this would be false. So the original statement, the conditional, and the contrapositive always have the same truth value. They're always going to be the same. True, true, or false, false. Okay, so we could practice more of these, but I am going to save it until I see you, because I know this video has to probably be getting long. But those are your words, those are some examples, and hopefully it kind of makes sense. And smiley face. Thank you.